So, welcome everyone to the lightning talk sessions. Are you excited? Are you excited? Great. So, this is the session one of day one. So thank you very much for coming. So this is the history of the lightning talks at BlinkOn. So this time, we have 36 lightning talks. And this is showing my excitement. So my excitement has been increasingly, monotonically increasing, and I am more and more excited. And as always, we have one important rule. So I asked all the speakers to insert one talking point that will get a storm of applause. So when you find that point, please give the speaker a big round of applause. Is that okay? Okay, so let's practice. I am pushing forward modification and onion soup. And so many people in so many teams have contributed to making progress, and it's so amazing. So what's the current status? So it's amazing. So modification is 93% done, and onion soup is 87% done. All right, so I want to call the first speaker onto the stage now. So Yose.
Okay, so I'm Jose Dapena from Italia, working for the LG Silicon Valley Labs. So let's cook. So we have these ingredients: webOS, that is a web-centric OS using LG webOS, MacTVs, and other products, using Chromium, the web runtime for running web applications. Open embedded that makes things easy to deploy products to embedded devices. And ROS, that is a robot-centric OS and stack for integrating communication and manipulation of the robot parts. Okay, so steps. We throw all in the pan, we compile, and after some time, we get this. Okay, so yeah, you have the specifications. It's a Raspberry Pi 4 with Thunderbolt 3. Yeah, the features. We have Chromium inside, so integration with robot services and everything. With our web application, we can use WebSockets to talk to all the robot parts. And yeah, all the power of the web platform. We have voice control, motions detection, over-the-air updates, navigation, and a companion web app to control the robot. So thanks.
Thank you very much. So the next speaker is Yoichi.
Hi, I am Yoichi from Tokyo Network team. Today I'm here to present how I improve WebSocket performance improvement. Ian talked a bit about that today's morning. So What is WebSocket? WebSocket is a API that enable web browsers to bidirectional connection to server over TCP. Code is like that. You can create WebSocket instance with a WebSocket URL, and that starts negotiation immediately. And with the instance, you can listen message from server. And of course, you can send a message to server. That's all. It's old, but really well working API. So, what was the problem? It's about download speed. If you download array buffer or binary in JS from server, Chrome was 3 times slower than Firefox. So, what was bottlenecks? Roughly, there were 3 areas of bottlenecks. One is Chrome extension proxying. The so-called Chrome Web Request API that always proxies WebSocket connection. That slows performance down. And the second is small read buffers that was used to read buffer from TCP read, and there are another small buffers for module pipeline. And finally, there were so many copy operations during the procedure. So, but I was skeptical that because WebSocket is so well-working API. So, was there really such messy copy operations? There was. Actually, the original WebSocket implementer stated here to avoid remove this copy operation. Let's do it. So for proxying, we remove the redundant proxies, and for second small read buffers, we optimize buffer size, and finally we introduce memory shared algorithms. Okay, then next comes results. Yeah, we got 4 times faster. And how about other protocols? Yes, for Mac, we got 8 each time faster, and for Linux, we got 7.5 faster. And then now Chrome is the fastest browser ever. That's all. Thanks.
Thank you very much. So the next speaker is Jinho.
Hello. Hello, my name is Jinho. I'm a software engineer at Samsung browser team. Our browser implements biometric authentication for personal security, like this screen. For example, it is used in autofill and web payment. Anyway, recently I studied servicification concept. It's a really interesting topic. So I tried to migrate existing authentication module to new service concept. It's really nice, but the service is always asynchronous. So what's the problem? As you know, it causes callback error and to large code diffs. To fix the problem, I thought we need a async await mechanism like JavaScript. So I tried to implement my own coroutine in C++. To implement this, the important thing is how we can suspend and resume the coroutine at the specific point. Then, how can we do that in C++? In case of C++, switch case statement has two magical abilities like this. If we use them, it's possible to suspend and resume the routine. It looks a little bit hacky, but it works well anyway. Yeah. Anyway, we can wrap the code using McGruer for convenience. Then we can make a simple coroutine like generate a function in JavaScript. But there is a problem. Stack is not working in the coroutine because the stack might be destroyed by return statement. To fix the problem, I used lambda capture. If we create the lambda object on the heap, then the capture variables are kept until lambda is destroyed from the heap. Another problem is that movable object cannot be copied in the lambda. For example, unique pointer. So I added a wrapper class to make the movable object copyable. Yeah. Finally, I could implement call wait by using callid and callresume macro. This looks a little bit hacky, but it makes our code very clean and simple. Yeah. Yeah, you can see the code at the link. Thank you.
Thank you very much. The next speaker is Anton.
Hey, my name is Anton Bikineev. I'm working on memory management and garbage collection in Blink. And today I'm gonna present a recent optimization that we did in the Blink garbage collector, which is called Oilpan. Oh, how do I use it? Like this? Oh yeah, here we go. So yeah, Oilpan is Blink GC, and the optimization is concurrent sweeping. So for background, what sweeping is GC phase which scans all allocated pages. It reclaims memory occupied by dead objects, and because it's C++, GC, it also calls finalizers on those objects. And this is a picture of ocean garbage collector, which I think of like a sweeper because it makes actually the same work. Like it goes over a huge area and reclaims, well, not reclaims, but collects garbage on it. So yeah, so before M78, the main thread looked like this. There was an application running, and there were some sweeping and finalization steps running in between. So with concurrent sweeping, it looks like this. The sweeping tasks go to background threads, and now it's clear that application has more time to do useful work. So concurrent sweeping was first concurrent optimization introduced for Oilpan. As I've mentioned, it was shipped in M78. It reduced main thread sweeping time by 50%, which means we now have less chunk. So yeah. But we still have remaining work, and those 50% of sweeping time are taken by finalizers, which are, like, as I've said, usual C++ extractors. We're still working on reducing them, and we introduced a couple of techniques like devirtualizing destructors in GC-based classes, and we also implemented a client ID check, which is called performance trivially destructible. You can use it. It hits like over 2,000 times in Chromium codebase, which is pretty cool. And we also want to stay ambitious, and we do believe that with your help, the number of finalizers can be reduced by about 90%. But for more details, please visit the Blink GC best practices session we are going to present tomorrow. Thank you.
Thank you very much. The next speaker is Xida Chen.
Hey everyone, my name is Xida, and I work at the animations team. Today I'm going to talk about off-main thread CSS Paint. So CSS Paint is an API that gives more control, but gives us more control on images in the web. So in this example, we have in the style, we have a background image, or it can be any image actually can be border image. Instead of give a URL, we give a paint function. And in the JavaScript, we register that that painter Dino to that class, to the class Dino painter, where in the Dino painter there is a paint function which takes a canvas rendering context and we can use the existing canvas API to draw anything that we want. In here, it's just an example where like we can draw a dinosaur with like path or with shapes. And this is more interesting with animations. In here, in the style, we can, in this case, we define a custom property called toSize, and we can add a static getter in the Dino painter to get the value of that custom property. Then we can animate that. We can animate the toSize defined in that animate function. And with off-thread CSS paint, the animation runs on the compositor thread, not the main thread. So you can imagine that it's similar to the opacity or transform animation. We don't have to interact with the main thread. So the current status is that we enabled it by default maybe a month ago, and we found there's a bug. It's not working with OOP-R yet. So we are trying to fix that, and then we will be able to ship it again. So please try it. All you need to do is to run Chrome with enable Blink features equals to off main thread CS paint, and we love your feedback. And that's it.
All right, thank you very much. So the next speaker is Xida. Again?
Okay, so my name is still Xida Chen, and I'm still working on animations team. So in the last 2 months or so, I have contributed quite many tests to WPT. Particularly, they are all interpolation tests. And today I'm going to talk about how easy is it to contribute to a test to WPT and the benefit of doing that. So this is an example of porting a non-WPT test to WPT. So all I did was adding some standard header, for example, a title, a link to the spec, and some of the test harness script, of course. You can see the style isn't changed at all. And then in each test case, what I changed is from the function called assert interpolation. I changed it to test interpolation because that's the test interpolation. I mean test underscore interpolation is the function name where the test script accept. And then in each test time, like at -1, at 1, instead of saying is the expected value, I changed it to expect the expected value. And that's all. That's really what I did to port a test from non-WPT to WPT. So so far we have ported 109 tests, probably more. 109 tests is the number that I counted a few days ago, and this number is going to keep growing. We are committed to port more tests to WPT, and we have filed in total of 10 bugs against Chrome and Firefox. So thank you. So if you are thinking of writing a layout test that tests some API, I encourage you to contribute to WPT directly. So our next step is to port more compositing tests. That's it. Thank you.
Thank you very much. So the next speaker is Rahul.
Hello, everyone. I'm Rahul Arakeri from Microsoft, and I'm going to be talking about compositor threaded scrollbar scrolling. So a quick background of why we are doing this. Scrolling using the scrollbar as of today in Chromium happens on the main thread. So that obviously means if the main thread gets busy and you try to scroll using the scrollbar, the experience is going to be like really janky. So offloading this off of the main thread and onto the compositor thread is going to help us save precious main thread time. So here's an example of how bad it can really get. I have a simple test page with an animation that's running on the main thread. And let's say you induce some jank on the main thread and you try to scroll. You can see that it's like pretty choppy. And By jank here, I just mean like some busy JavaScript running on the background. And this is how we are planning to fix it. Everything you see in orange is new code. So looking at this diagram from left to right, you can see that the way this works is a mouse event comes into the browser proc. It gets forwarded onto the renderer. There, the scrollbar controller samples the event and sees which part of the scrollbar is being heat tested. And based on that, it creates scroll deltas. And with that information, we can then go ahead and create synthetic web gesture events and add that to the compositor thread event queue. And from that point on, the gesture event handling framework pretty much takes care of the rest as the gesture events keep getting dispatched at every vsync. So with the feature turned on, you can see the improvements. We have the same test page. You start the main thread animation, you induce some jank, you try to scroll, and it's nice and smooth now. Thank you. So some final thoughts. We posted the intent to implement back in March. It's gotten a ton of positive feedback. Thanks to all the code reviewers who've been giving feedback, especially David Boken. I've been working closely with him for the past couple of months. We are planning to start trials in the first quarter of next year. Please try this feature out. It's pretty easy to locate. Just go to Chrome flags and type in scrollbar, and it's pretty much the first one that pops up. And as always, if you have any questions, please feel free to email me. My email address is arakeri@microsoft.com. Thank you. That's it from me.
Thank you very much. The next speaker is Jaeyong.
Hello everyone, my name is Jay. I'm a contributor for Chromium and worker for Samsung. Today I'm gonna talking about my contribution experience. When I started my job, I wanted to be a developer, but unfortunately my first department is not related to develop, so I can't. I really wanted to develop, so I looked for ways to grow out of work. At the moment, I found an event called Contribution in Korea. The contents of this event help open source contribution beginners by mentoring. A lot of projects on there. I choose the Chromium because it looks so cool. Before I contribute Chromium, I feel like I can do whatever, but really it's not easy. Already we know, right? Because it's a best project, right? But I try too hard, and the reviewers helping me a lot of things, coach me step by step, and thanks to helping, so I resolved the issue like a good person issue. The more and more resolved the issue, it made me interesting and felt growing. My daily life has changed to open source 25 hours. As a result of my hard work, I got some offer from my mentor. He suggested me joining on his browser developer team. Conclusion, I got two things from open source contribution. First, I become a browser developer. Second, I can do what I love. Thank you for listening.
Thank you very much. So the next speaker is Jean.
Hi there, I'm Gene. I'm with the animations team, and I'm going to talk about something that Xida did. But basically, he was up here twice already, so we don't need any more Xida. Well, sorry, we'd love to have lots more Xida, but this is my chance to talk about this. So the graphics metric team is a cross-functional team of people that are trying to land a whole bunch of graphics metrics, because we figure metrics are a pretty important thing in figuring out how the browser is doing. The thing that we're trying to do ourselves is trying to define a high-level metric of how good is the user experience on this website. And we have a hunch that, the loading is great. That's an important metric, and we've been doing a lot of energy on focusing on that. We'd like to also have some high-level metric that tracks the user experience after they finish loading. Are they getting stuff done on the web? Are the animations coming in a timely manner? And is scrolling happening quickly, for example? So we decided that a first cut at this would be the throughput metric. Throughput is basically the same thing as like a frame rate in a video game, except it's normalized because we've got a whole bunch of devices out there and they have different frame rates. So you wouldn't want the high-speed devices to dominate the metrics. So it's normalized to whatever we're expecting to get. So all of this landed in M77. Okay, so that was the clapping point for this whole thing. Some of you might have looked at this graph and realized that this metric needs some work still. Basically, the website that you see here, you can see that it's got kind of lousy throughput. And this could be, your typically lousy website, and maybe this is what it deserves in a ranking. Unfortunately, this is Google.com's search results. It's actually a pretty good page, so it should be getting good scores. Our intention when we first put this metric out was that it would suck. It would really be bad, and then we would iterate on it. And based on the data of what we see on performant and non-performant websites, we'd eventually tune this metric to make a meaningful evaluation. So I'm just going to walk you through some of the debugging that we did on this. So we started with just as an example here. We've got two animations that fire on this particular site. One is kind of a lousy animation that takes 500 milliseconds. Another's a nice snappy one that takes 100 milliseconds. The original metric that we landed in V1 would have given this a 32 and a 66% score, which are two kind of meaningless scores. We're trying to find meaning out of these scores. This is kind of problematic because at that point, we were reporting one metric at the end of every single animation. So if you had a whole bunch of those 100 millisecond animations, they would dominate the results. And if you had another animation that maybe ran perpetually, it would never report on its results. So obviously, we could do better than that. So what we did was we broke things down. Every 4 seconds, we would report the results. This particular example site is now giving a 38%. Again, a fairly meaningless number. Is that good or bad? We don't know yet. But we figured pretty much that this one is pretty gameable because you could imagine doing a whole bunch of really fast single slice animations and they would all get 100% and then your average would boost up way to the end. It's a obviously very gameable metric. So what we did, we measured it every 4 seconds, assuming that all those frames that aren't animating are actually doing fairly well. So this is V3. We expect somewhere around V12 that we'll get to a metric that is actually useful, meaningful, and helpful to us. And if you want to come talk to us, we have a session tomorrow talking about at 10 o'clock. If you can join us and talk to us about metrics and give us suggestions. And
thank you very much. So the next speaker is Hitoshi.
Hi, I'm Hitoshi from Bindings team in Tokyo. First, we introduce ourselves. Bindings team is now renovating the IDL compiler system that generates the code from the IDL files. And now we already, it's possible to generate the WebIDL database that contains all information that written in the IDL files like this. And of course, the database is usable in a Python script. This database has 2 strong points. One is that all the objects are directly linked with each other. And the second point is that it's easy to access everything. Nothing is filtered. These 2 points are very important to replace the running IDL compiler system and to work for the issued file for the current system. Let's see in an example. This function f returns the prototype chain list from the given interface I. The green arrow shows how the directly linked objects can be accessed. And then you can use the interface from the database directory with that name, and you can you can dump the name of the interfaces in the product chain of the HTML element in this example. So to show the power of the database, let me ask a question. Which of the following interfaces has more attributes, including its inheritances and mixins? A is a window and another one is the HTML window. We think window has more attributes. No? Oh, not so many. And how B? HTML document. Oh. Let's see the result with the database. The window has a 185 attributes, and HTML document has 188. So the answer is B. This example is very easy example, but we can use it in a powerful way. And our team is renovating the IDL compiler and now developing a new code generator based on this database, and ready to replace the V8 binding. And we also working for the WebAssembly bindings at the experiments. Thanks.
Thank you very much. So the next speaker is Stefan.
Thank you, Adithya. Oh, I thought there was a mic still. There is a mic still. I like to walk and talk. Hi, I'm Steven. I'm here to talk to you about the MDN survey. So what is the MDN survey? In July this year, the Mozilla Developer Network ran the largest ever survey of web developers. 78,000 replies, 28,000 of those were full responses. We translated it into 8 languages. We got responses from 169 countries. 10,000 hours were spent answering this survey. That's over a year of time. Who did we hear from? Well, it turns out when you ask web developers, you hear from web developers, so that's good. 85% of people said that they were professional web developers. Most of them came from organizations. Some of them were freelancers. When you ask them to describe themselves, most people think they're full stack people. A good number of those, it biases towards front end, really. In terms of experience, we actually heard from the full slice. We heard from people all the way from new grads out to industry veterans. They all responded to our survey. Interestingly enough, actually, not on this slide, but in terms of countries, America was less than 20%. We heard from all of them pretty evenly. It was pretty awesome. And sadly, in terms of gender, 85% of respondents self-identified as male, 8% as female, and other. What did we learn? So we learned that even in 2019, only 60% of web developers support the mobile web. Doesn't seem great. In terms of browsers, it's really interesting. Chrome and Firefox, 90+% of support. Then suddenly you drop off a cliff. Safari, Edge, Android, 60%. How about satisfaction? It turns out 75% of web developers actually say they're satisfied with the web, which seems great until you flip the number and you say 25% of web developers aren't satisfied with the web. That's terrifying. We should do something about this. What's making them not satisfied? We asked them to rank their top frustrations. What are they upset about on the web? They said this. These are the top 5. Those are all interop. Arguably number 4 is also interop. So developers really care about interop, and we are not delivering. We asked them what's missing from the web. They said access to hardware, number 1, so Fugu team, good job. Number 2, interop, comes up again and again. What did we not learn from the MDN survey? So we only surveyed web developers. So bias, right? We're missing everyone that doesn't develop for the web. Everyone that left the web or never came to the web, we don't know what they think. MDN is a documentation website, so I assume that people go there because they're looking for documentation. So what sort of bias is that? I don't even know, but that's bias, right? And the questions were pretty high level. We want to drill down into this. We want to ask follow-up questions. And so we need to figure out what to ask. So if this interests you, if you have questions, if you have concerns, if you have ideas, please come talk to me. If there's enough interest, I will add a session using our awesome little thing that Ojan built. And finally, thank you, MDN.
Thank you very much. So the final speaker is Adithya.
Hi everyone, I'm Adithya. I work on the Chrome team in Waterloo. So I'm here to talk to you about portals, just in case you're out of the loop. Portals combine two things really, content embedding, think iframes, and this new functionality we call portal activation that helps you take these embedded frames and make them the top level frame. We think combining these two together gives you the appearance of instant navigation, which we think is going to be amazing for the web. So what have we been up to since the last BlinkOn? We've implemented post message, which is a way for the portal to talk to its embedding page and vice versa. We've worked on getting portals to respect CSV directives, in particular frame source and frame ancestors, which are to do with frame embedding. As you can see from the little picture there, portals do respect frame source. Frame ancestors is work in progress. We realized we had to refactor the current way we enforce frame ancestors and moved it from the browser, from Blink to the browser process. That's actually done and has been landed behind the flag. We've also been working a lot on history. History is very complicated, to put it mildly. And we've had some discussions with Chrome UX and decided on what we call a linear model. Basically what happens is portals only affect user history when they get activated. And when they get activated, we only add their last committed entry to user history. Any previous navigations are just ignored. We've picked this model because we think it helps accomplish our key objective, which is to take users back to the last thing they saw. Implementation, work in progress, so many details. Finally, we've been working on fixing DevTools for portals, but instead of explaining it to you, I'd rather show you a demo. So this is what it looked like before you try inspecting a portal, click on it. Oh, there's apparently nothing in the portal, great. And if you tried activating it, the window just disappeared. Terrible, terrible experience. We got a lot of complaints about this, including someone mentioning it in their talk. After we've put some work into this is what it looks like. Inspect the portal. You can see its contents in line. You can actually execute code in the portal's frame. So I'm about to change the color to pink, I think. Yep. And now when you activate the portal, the window sticks around. Thank you. You clearly didn't need that slide. Feel free to file feedback on one of those two links there. Thank you.
All right, so finished. Yes. So thank you very much for joining the session. So tomorrow we will have 2 lightning talk sessions. So see you tomorrow.